then one thing that comes up and actually plays a large role in fueling our next topic, which is solid waste production, is mining. And the nice euphemism for this is non-renewable mineral resource extraction. Okay, but what we really mean is mining. And hopefully that gives you a vision of what is happening in this process, and likely what you're envisioning is correct, actually. This is a copper mine, I believe, from the start of our textbook here in chapter 14, which is about mineral resources. This is a copper mine, I believe, in Utah. It's what we call an open pit quarry mine, where they have, you have been to this one? It's cool. It's this huge, vast pit that's dug in the earth's surface, and as they remove the soil, the sediment from this location, they can extract minerals, and we'll talk about what is a mineral today, that are useful for us in society in a variety of different ways. And so this encompasses and will get us into thinking about fossil fuel extraction, which definitely things like coal bridge this interesting intersection between mineral resource extraction. We're really thinking about rocks and elements that are coming out of the ground. And another type of non-renewable resource, which is our fossil fuel extraction, which plays into, again, our extraction, our influence on the land and the air and the atmosphere around us. Rebecca has said she has been to a mine. Has anybody else been to a mine?
So that's specific.
Yeah.
It looks like an amphitheater.
It does. It has the same structure to it, and we'll talk about a little bit why that is, why they cut in this particular fashion. Anybody else been to a Been in two, but I have not been to an open quarry pit mine. I've been down in two subsurface mining locations, one in Canada and the other in Mexico, where I was sampling subsurface water for viruses and bacteria, which is what I was doing at Postdoc at the time. The guy that I worked with was relatively well known within the field, and so you'd always get asked to go on these kind of crazy excursions. Two of us to go down in mines and look for bacteria and viruses. And he was like, I ain't going, you get to go. So I went. And I was an experience. But it gives you, I think, kind of like agriculture, being around a mining operation kind of gives you a new perspective for the hazards that are inherent to this job, first and foremost, human health and safety on the job. And also, why are we doing this? What is the scale of these projects? We see these pictures and recognize that this particular pit in Utah is like 4,000 feet deep. Okay, like it's enormous. Okay, we're talking about miles that we have dug down into the Earth's surface. And why do we do that? And we do it because it's profitable. And it's profitable because we use these mineral resources in a variety of ways. All right, but first I have a review question for you. What are your top 4 concerns when it comes to modern agriculture? I listed some of my top concerns last week as we were talking about modern agriculture. Talk to your neighbor, see if you can come up with 4 big concerns that you recognize that I just said that we have with modern agriculture. We know it's good for us. We know we have to do it, but why is it also bad?
Sustainability, right? Just in general, not cropping crops. Actual farmers. It was like I think I wrote it down. It's funny. Yeah. We have less diverse crops though since the green, what you call it, green revolution. What did they call it with the farm? There was a name, wasn't there? Yeah.
Oh, wow.
Yeah. No upcoming generation of farmers to.
Yeah, they're all old and and no one's learning how to farm right.
It's the
Sustainability about the irrigation system.
yeah. That's gonna bug me. There's a whole thing about like the old white dudes.
Yeah. All farmers are old white dudes, and no one in their families are wanting to do farming anymore. So Yeah.
Okay. All right, give me a concern with modern agriculture. GMOs, Elena.
Sustainability,
Sustainability, and why are we concerned about its sustainability?
soil exhaustion, irrigation,
Crop
Water
diversity.
use, yeah. Okay, what else?
Farmers.
Farmers, we have a limited resource in farmers, definitely.
loss of biodiversity.
Good. And this comes, recognize this comes in at least two ways, okay? We can think about monoculture, where we're growing one thing where there used to be many things growing. And we can also think about the effect of our pesticides and herbicides and fertilizers that tend to promote or change biodiversity in and around the fields. Yeah.
Doesn't it also change biodiversity of the soil?
Yes. And again, that's largely an effect of these things and how that influences the soil microbial community. We haven't talked about that in any kind of detail, but it goes along with our concerns about soil exhaustion and soil chemistry. And as we disturb this microbial community, the release of greenhouse gases as they change their metabolic process. Cool.
Water waste,
Good. And again, we can think about freshwater use.
soil exhaustion,
Yeah, I got that one.
working conditions.
Good, and again, it's not just the farmers themselves, but the people who are on the farm. They may not be the owners, but they're responsible for helping plant, harvest, process the crops. And we focus really on what's happening with farm workers in the field, but recognize that outside of just the agricultural farming community, we'll have stock husbandry. There's a whole suite of processing manufacturing jobs that pay minimum wage. We recognize that minimum wage might not be equivalent to an actual living salary. Yeah.
Pollution?
Good, we get a variety of types of pollution. Where does that pollution come from?
Runoff mostly?
Yeah, mostly this stuff. We didn't focus on it, but we do have a variety of carbon dioxide and methane that's produced from these processes. And those are both really important greenhouses. Yeah.
Sustaining the economy,
Good. So we have concerns with economic sustainability. This comes from the subsidies that we pay. You know, we're paying out money in order to get certain crops. But then also, you know, we haven't talked at all about food prices that we pay as consumers for this stuff and how that has changed and how food is along with rent, an ever-growing portion of a person's income and paycheck that you have to pay for this. Because we don't actually grow the food ourselves usually. We aren't self-sustaining, particularly in urban environments. Yeah, go ahead.
Having the yield to like provide for the growing population.
Good. And long term, we have all these concerns, and we've largely created these concerns because we have been increasing agricultural yield. We've been very focused on how can we feed an ever-growing human population or provide for them all these different products that come out of agriculture. Can we continue to do that? As we start to see the detrimental effects build up of modern agriculture, we start to really be concerned about yield. Is there more land that we can turn into agriculture? Yes, no, maybe so. And these consequences, is there a better way to do modern agriculture? Which is where we kind of left off our conversation last Thursday. We talked about local, we talked about organic agriculture and what those terms might mean and how they might be beneficial. Those processes we came back to had this same concern with yield. That somehow, if we're going to manage agriculture in the future, it has to be a combination of modern industrial scale agriculture because we have to get yield. But we need to start incorporating or transforming high yield agriculture into aspects of organic and local so that we can start to stop some of these other problems that we're really concerned with. Is everybody with me? Okay. I think that for us, you know, many of us are not, including myself, we're not like, oh, I can suddenly become a farmer and I can grow my own food and I can stop being part of this process. Okay, I can stop eating into this cycle. That's not really an option for most of us because we have chosen other career paths, because we you know, they don't have the treaties or the land that we're taking down to support ourselves. What I want to leave you with as we stop talking about modern agriculture is this idea of what we call urban agriculture. And it goes along with urban environments, and it's where the two really tie together. And urban agriculture is an idea that we're doing crop production in high-density human environments, where we take a portion of the land that's in the urban environment and we start to grow food. And we start to grow food so that the urban environment can become self-sustaining. It will probably never be self-sufficient, but remember that those urban environments use 75% of the resources, both mineral we're going to talk about, as well as agricultural productivity. If we can take some of that land footprint that's in urban environments and utilize the vertical space that urban environments have built themselves into to make crops, it can really help us when it comes to urban agriculture and productivity, and it can help us move away from the harmful land impacts of some of modern agriculture. There are real consequences that come with urban agriculture. It's much more water intensive, it's much more energy intensive, because you have to provide light and water to these crops that they would normally get from the environment, but we now have to provide them. But there are some benefits in that we can tie people back to the food that they're actually eating. You can become a little bit self-sufficient in the food. You can cut down on transportation costs as well as greenhouse gas emissions. It really reduces fertilizer usage, usually because the systems are very tied to where one crop is producing exactly what's needed by another. This happens most often in hydroponic situations where plants are growing in water environments largely where their roots are in water. And then you have some type of fish usually that's in the water that's eating a little bit of the plant matter and then is releasing waste into the water that provides the nutrients directly to the plant. So you can kind of get these really interesting closed agricultural systems. When you go full on kind of technology, I guess I would say. Rebecca.
I love that urban agriculture because we were talking about the food deserts in the grocery stores, and one of something that's really cool are the after-school outreach programs where they do the urban agriculture and the
Yeah.
kids get to learn to grow their food, cooking classes, and they get food that they wouldn't get because their grocery stores don't carry.
Right, and this is part of the solution to those types of food deserts. This is part of the solution to the land-human disconnectivity that comes with an increasingly urban environment, where you see a green space just as a parkland rather than as a place where we grow food, where we get textiles and fibers, as well as lumber outlets. So a different appreciation of the space that we're in. Caleb, I know you had a question. Okay. Yeah. And that's becoming a popular trend. And that's the idea that you, even if you live in an apartment or you have a very small lot, and you're like, I can't have a garden on my area. We have places in the city where we're not having human habitation. It's not going to be zoned in the middle of the suburb. It's not going to be zoned industrial or commercial anytime soon. Can we transform that land not only into a park, but into a place where we can actually grow food? We can rent a plot for $30, $40 a year. They'll put really nice loam, hummus mixed in it, and you can actually will grow big, valuable crops. But you have to tend it. You can plant what you want in it. Usually with the understanding that you won't grow something that will overgrow the next person's plot. Caleb.
How much do they think this would help? Like a lot, like 70% of people had gardens and got at least some of their food from.
Oh, yeah. I think it would help tremendously. And our best examples of when this worked really well is when we had victory gardens during World War II. And we asked, everyone in the United States to plant a garden to grow your vegetables. One, because we didn't have the labor force out there in order to plant and grow these crops anymore because all of our farming community was literally at war. And two, because we weren't going to be planting crops, we weren't going to be harvesting them. And two, because we needed to transform our workforce from agriculture and large-scale agriculture into industry to build the things that we needed to win the war. And so you needed to be growing a small plot of your own food so that we could take workers from the fields and put them in factories. And that worked. Like, people were able to grow the crops native to their area and provide for their own tables. And so there wasn't a pressure on the grocery store. We didn't, there was rationing during World War II, but it wasn't centered around fruits and vegetables. It was a little bit about flour and sugar and things like chocolate that were going into the industrial food production to go to the trees. Because people were growing their own food. And then as we started to have manufactured products, it was so much easier to buy those things off the shelf than to grow and can them and prepare them yourself, that we stopped with the kind of victory gardening thing. We could totally go back. The suburban environment is perfect for victory gardens, where you have this big honking lawn, take a little bit of it, make a bed, grow some of your vegetables. Okay, and especially grow the things that you like, so that you're going to use what's actually coming out of your garden. You put less pressure on the grocery store. Totally. The idea is like, you have to be like, oh yeah, that sounds like a great idea. Okay, like right now we're not in a place of food scarcity potentially like we were in World War II, where it was kind of like, I have to do this or I might, starve or I'm going to really miss out on some of my nutrition. That's not the pressure to do it anymore. And so there's much less pressure to have your own garden and to be a bit self-sufficient, because there's a food abundance in our country.
Shouldn't have been like a tax break.
Potentially, or you have to really like it. And there's a growing urban agricultural movement on the small scale, largely is what it's focused on, in order to grow food. This is part of the local food movement. Again, the idea that at local restaurants, they're starting to try to have products that are locally grown. And so that's where some of this large-scale urban agriculture that you see here feeds into those types of products, where you have to provide a constant supply chain to a restaurant. And you're going to have a bigger production than the kind of thing like backyard garden. But it moves into that idea. Yeah, Willow.
And then there's like hydroponics, aeroponics.
Yes.
But like which one is mostly used? Like we have a hydroponics downstairs set up.
Yeah.
Nice for projects and I use that all the time. But
I would say that hydroponics has a bit of a longer history, and so it might be something that's more utilized. It's definitely more water intensive for these large scale, whole floor of an apartment building, garage complex, or a basement sublevel of a commercial building. It's easier to start a hydroponic system, and they're more stable because the water gives you this huge buffer that you're missing from the soil. Aeroponic systems are like this one over here, where they've got the plants usually, and there's no soil or water that the roots are in. They're growing in air, and you have to mist them with a nutrient mix every so frequently. And that works, and it can grow crops totally fine, but it's just like less done. And I think people have a less of an understanding of how this is going to work.
I've used hydroponics.
Have an airplane.
You have an airplane to kill it, right? Like these things are very also popular home design.
The shoe sack looks pretty.
Yeah, the shoe shack garden is really nice. And again, this is where they planted in soil, and they take in, a little pocket protector type device, and they put it on the wall or in the roof, probably of their apartment complex or on their balcony, and they can grow plants. Again, that they want to grow in that particular soil environment. They take upkeep. Okay, I think that's the thing that keeps most people from engaging in urban agriculture, whether it's small or going all in and doing large-scale urban agriculture. It takes upkeep, and it takes an upkeep that we're not familiar with because we haven't been raised for a large part, and there are exceptions to this, of course. We haven't been raised growing food. We haven't been raised working in the dirt. Like sometime when you turn 10 to 16, all of a sudden you decide that playing in the dirt and making bug pies is not cool. Okay, and so going back to it, there's always a bit of a turnoff. There's a barrier that you have to overcome. But it's part of the balance that's necessary if we're going to avoid the problems and concerns that we have with modern agriculture as we continue to increase our population. Urban agriculture is part of the solution to our land use problems. Okay, we need to grow our communities wisely. We need to think about what suburban sprawl means and looks like. It's really cool. I would totally live in a place like this. Okay? And I can envision myself living in a building like this where I live on one level and I teach because the university's on another level, and we go and do lab in the forest and on the prairie that's in the building as well. And it's all entirely self-sufficient because it's generating its own wind and solar energy. And the water that we utilize in our toilets is gray water that comes from roof runoff. Okay, there's ground that again you can think of as being commercial or housing or industry that's below ground might be tied into the public transit system.
That's gotta be,
It's a huge footprint, and so most of the buildings that we see being built like this are done in Asia. Oh, I had like 2 dropouts today already. Are being built in Asia, where they have opportunities to house lots of people, and that they can utilize the newest technology in building design as possible in order to do this in a green fashion.
has somebody built something like this already?
I don't know if they've done one exactly like this,
There's three.
but it's an increasing idea, and some of the really neat things that are being done in the large Asian cities, particularly in China, a little bit going down into kind of Indonesia, the Philippines region, is this idea of almost designer boutique apartment complexes, where they are designing to be self-sufficient. They're like, you never have to leave the building. You can get everything you need, including your recreation as well as your food production. Definitely, as we kind of recognize going forward in how we want to transform our economy, you know, you might get credits for working in the forest or the farm in these buildings that would help go towards your rent and make these more affordable. We don't see a lot of these types of buildings in the United States yet because lots of our urban areas are built already, and this would mean taking down a building and putting up a new building. And so much more of this is new construction. Even it's not. We see green walls, we've seen urban rooftop gardens as an increasing thing as we gentrify our urban communities, but we see very few kind of totally self-sufficient. But you can do it. Like you have to choose that. You have to be willing to pay for it. Yeah.
Cost is always an issue.
Right, a lot. And I think that's the main factor in gentrifying or rebuilding in this fashion is that it's costly. It's costly to get what we would call a LEED standard building, whether that's kind of LEED certification, which is where you have this type of leadership in environmental engineering and design, where you get credits for building with reused materials, for building for heat and air conditioning efficiency, where you're going to use gray water, where you're going to have these types of green standards. It's expensive to get that kind of certification, but then it's a premium you can charge for rent as a building. So you are in a sustainable building at one level or another. Yeah.
What if they just built the green part of it?
Do they just build the green part of it?
Yeah, so like instead of the rent and the self-sufficiency part, I mean,
Yeah.
I think people would, I mean, you could hire somebody to work as a person in just the 3 stories of.
Totally. Like, yeah, that would be like one of my dream jobs. You know, like a forester in this type of area.
I mean, even like build it in a community, like build it in a community.
Yes.
It's like a co-op
Exactly.
commune mentality
Yes.
versus.
This is the idea of the co-op or the CSA, where you have community-supported agriculture. You say, I'm going to buy a share of the farm produce. I might spend some time working on the farm in order to get a discount on my farm produce. On my farm produce, and I will do whatever you grow on the farm.
So it's like a return to basics. It's going back to how things used to be done, but in a way that facilitates modern culture.
Yes, it's this idea of incorporating what we traditionally have done and know, where we lived within the bounds of nature, with our modern technology, with the advances that we can actually have in absolutely make it better. It's totally possible. It's way cool.
This became like a big, like say that this became a big thing. What would happen about that agriculture system when we have, like, I know.
It would still be there, and we would still probably, if it just went on business as usual, we'd still have these same problems with it. But we'd be less dependent on it. There would be less pressure to expand and enhance the current problems just for yield. We can start to become self-sufficient in urban environments, which puts less pressure on our agriculture. And that way land can rest. There can be less of a chance of soil exhaustion. Less concern about these problems being exacerbated.
This almost feels like one of these things, but let's just take a city for example, and it's self-sufficient. I feel like we're going.
Okay, and that, again, that's the transformation that I want you guys to be ready to embark upon. Because what do I need to do in my life to help me be more self-sufficient? I may not be able to go all in and find one of these buildings and live and work in it, but, what are the small steps that I can take that put me on that pathway? What can I do in my local community that helps us be more self-sufficient? How do we get the people in my community to be excited about this type of living? Continue to talk about this for the rest of that. But we need to move on to something else, which is maybe the opposite of growing things, which is ripping things out of you. Which we do with agriculture too, but in maybe a slightly more sustainable fashion. We need to talk about our mineral resources that we take out of the earth's surface. Kind of how today we'll think about how these minerals are formed to some extent. We'll do a little bit of geology today. And then we want to think about how we mine and what the consequences of that are, again, kind of from a very environmental, economic, and social perspective. Recognize that when a mineral resource is found under the surface of the earth, oftentimes the extraction of that mineral trumps the other uses of that land. If we need to mine a rare earth element that's utilized in making cell phones, in this particular location, we're going to tear up the agricultural field. We're going to move the community that's there potentially in order to get access to that mineral resource. And so this is something that is perhaps newer on the scale of human civilization, although we've always utilized minerals and resources around us in a variety of ways. Mining and the full-scale extraction of these resources has really benefited from engineering and technological advances within the last 150 to almost 50 years. And because of our ability to get our hands on these mineral resources, we've transformed our society to be very dependent upon the technologies that these minerals enable, like computers, like electricity, like cell phones. All of these minerals and the mining that produces them has become economically profitable because we want to utilize the goods that they're in. Okay, so today we're going to talk about a little bit of geology, processes that produce minerals and rocks. We'll look at some different mining strategies, and we'll consider the consequences of this extraction. Mining scale processes, as I mentioned with our first slide today, are enormous. They take and utilize a tremendous amount of rock sometimes to get very small amounts of useful minerals out. The dump truck that's in this picture, the wheels are as taller than a man standing. Okay, the scale of these operations are vast and enormous, and because of that, they have real impacts on the environment around them because they are so large in scale, even though they tend to be very localized in where this process is actually happening. Okay. So a little bit of geology to start us out. We can think about geology and the process of studying the Earth's dynamics, geologic or rock processes, as a very interesting area of research. It's only relatively recently that we've really been able to plumb the interior structure of Earth. It's relatively recently that we recognized the Earth was a sphere and accepted that it was a round structure and not flat. The scientific study of these different minerals, where we find mineral deposits in reserves, how they are formed and change over time, is something that feeds directly into our economy, and is something that has become of increasing economic value as more and more of these minerals find a place within our social civilization structure. You probably are aware that there are 3 layers to the Earth's structure. The innermost layer of the Earth is the core. This is largely composed of iron with some nickel thrown in there. It is solid at its very core, and then there's a bit of molten metal that swirls around in there. This is what creates the high density of the Earth and gives it a large portion of its gravity, of course, that helps us stay stuck on the surface rather than floating off into space. It is very, very hot there because of all the pressure exerted on this iron core from the layers around it. And that internal heat structure also influences the movement of the mantle, the layer of the Earth above that, as well as the lithosphere, the tectonic plates that form the crust of the Earth's surface. So above the core, of course, there's the mantle, which is the red text that's on here. The mantle is the middle layer of the earth, of course. It's mostly solid rock, and definitely where we interact with it in terms of our mining processes, which we don't mine into the mantle, but we have delved into the mantle of the earth with some of our scientific research. It's largely solid, but again, because of the high heat and pressure of the mantle, this rock can be very pliable, and it definitely flows in what we call convection cells. As the rock gets heated up by nearness to the core, it lightens and expands. Remember, when something heats up, its density gets less. And so as this rock layer of the mantle gets heated up by nearness to the core of the earth, it gets less dense. And so it rises up towards the surface of the earth. But as it gets away from the core, it starts to solidify as it loses heat, and it becomes more dense, which means then as it gets denser, it's going to fall back down through the mantle closer to the core. Okay? And this movement of rock on geologic timescales takes millennia for these convection cells to move around, moves rock around within the mantle, and it mixes all these different minerals and elements that are present on Earth in a variety of different ways. The portion of Earth that we actually live on is the top layer of the Earth, the third layer, and that's the lithosphere. It's the solid, rocky crust. That's the very few, kind of like 3 to 4 kilometers worth of rock that rides along this kind of semi-pliable mantle underneath it. Okay? As these convection cells are moving the mantle around, they're carrying with it bits and pieces of the crust, the lithosphere on top, and they'll move it all around the globe on these big geologic timescales. It's important to recognize that we have these different processes that are happening within inside the Earth because it's this heat and pressure that transform the mineral elements present in the crust of the mantle into the minerals that we utilize as these resources that we want to mine. Okay? It's these processes of erosion and melting and sedimentation that give us these minerals that we now find valuable. Okay. Are you guys okay?
Mhm.
You're like, yes, I remember this from like 4th grade earth science. Or scratching the surface. Okay, we talked about the crust, the earth's surface, and then the lithosphere. Okay. The Earth's lithosphere, remember, is composed, it's not a solid surface, the Earth's crust. It's broken up into plates or pieces and chunks that we call tectonic plates. The boundaries of the majority of the tectonic plates are shown here, and the white arrows are giving you some idea of the movement of these tectonic plates. Again, on geologic timescales, to hundreds of millions of years, these tectonic plates move slowly over the mantle of the Earth, and so they shift position over time. This is the current location of our continents, the above sea level portions of the Earth's crust. Recognize that the tectonic plates in the Earth's crust run under the oceans. It doesn't just disappear and become something else down there. It's still crust, okay? It's just lower elevation, so it's filled with water. As these plates move around, the size and the location of the ocean basins changes. The size and location of the continents changes. And that affects climate. It affects what species live where. It is a driver of evolution and natural selection as it changes climate in different locations. Yeah. Oh man, I think there are between 8 and 12 major plates, and there's another like 17 to 20 small plates. So for instance, there's a whole bunch of little tiny ones over in the Indo-Pacific region that are kind of like scratching around against each other. I act like this is something that happens in a visible fashion, but you can correct. Okay. The big plates are things like the North American plate, the South American plate. The Arabian plate there, you can see it runs up through northern India, Pakistan, over into Nepal. As that Arabian plate has pushed up into the Eurasian plate, that is what has raised the Himalayan mountains. And so recognize that even though this is not a visible process of these tectonic plates moving around, the forces of physics that they hold within them are massive. And they are major sculptors of the crustal features that we live with, that determine where we can grow food, that in some cases determine climate. We have these large mountain ranges that are produced. Not every mountain range is produced when two plates collide though, although that could be one of the things that does happen. Sometimes when two plates collide, other things happen, and so that's what I will tell you about. Just a brief introduction to it on the next slide. So in terms of our own crust of the earth, we have these tectonic plates, and they move over the mantle in a process we call continental drift. Okay, this is the movement of the tectonic plates over the surface of the earth. It varies, but they move on the order of about 15 centimeters a year. It's slow but very steady. And when two plates, either large or small, meet each other, you get a fault. Okay, you get an intersection between two plates. And in general, one of three things can happen, and some of the major health hazards to humans, natural disaster events are a result of the interaction between tectonic plates, the basic forces out of our Earth. When two plates meet, you get a plate boundary, or a fault usually is formed of one type or another. If you go out to the west coast of the United States, it's probably the nearest plate boundary that you can encounter. On the west coast of the United States, you have the Pacific Plate that is diving underneath the North American Plate. And because of that, the western portion of the United States is an area of very active tectonics. We have lots of gases that are released from the Earth's crust here. We have lots of lava that comes up to the Earth's surface as a result, and so a large, both volcanic as well as normal mountain chain in the western United States. Remember, Yellowstone is a huge geothermally active area because of this interaction between these two plates. And so again, think about the plates are actually interacting with each other off the coast of California, Washington, and Oregon, but the effects of them are seen all the way inland into Montana, Idaho, Wyoming, Colorado. All right, so there are these three types of plate boundaries. The first one is what we call a divergent plate boundary. And this is when two plates are not colliding with each other, but they're actually moving away from each other. Okay? This happens, again, when we have two plates that are moving away from each other, and this produces what we call a rift valley in between them. As these two plates are being produced, you have magma that's welling up from the Earth's surface, and it's pushing out to the sides, making new crust as it does, as that magma cools on the surface of the Earth from the mantle. And in the middle, you have this really deep valley that we call a rift. There are rift valleys in Africa where the plates are moving away from each other, and there's new crust being formed every day. We have big rift valleys that run throughout the mid-ocean region. Big chain of water mountains that circles through the middle of all of the major oceans and water. Okay, this is a site of new crust formation. But recognize that as we have this new crust that's being pushed up from the mantle at these divergent plate boundaries, it's not like the Earth is expanding and getting bigger, okay? That means that there has to be a place where crust is lost and destroyed, okay? And that happens at convergent plate boundaries, okay? Convergent plate boundaries are where two plates collide, okay? And when this happens, you can have an uppush of crust, you can build mountains, okay? Or you can have one plate, the one that's denser, dives underneath the other one back into the mantle and gets melted. Okay? And so it's almost like a crustal conveyor belt. We have new crust formed at the rift valleys. It flows across the Earth's surface, and then when it's plate, it dives down underneath. It gets consumed, or it rides up over the top. And so it's a full cycle. Okay, this is the rock cycle of the Earth. All right, it's making crust. At these convergent plate boundaries where you have one piece of crust that's diving under another, as that crust that's diving down gets melted, right, it makes magma, it makes these hot spots. And you get a big puddle of magma under the Earth's surface, and when you get enough of it, it punches up through the crustal plate above it, and you get a volcano, okay, you get lava. This can happen in the middle of the ocean where we have hot spots. This is what happens to produce the chain of volcanoes that brings the Pacific Ocean, known as the Ring of Fire. Of course, there are lots of hazards that come with this. We have, of course, volcanic explosions that can be quite dramatic. When you have this, you often have acidic springs that are present in these locations. You have an outgassing from the Earth's crust that changes soil chemistry. You have a particular group of organisms that adapted for life in these locations. Okay. cool. It's also gonna be why Seattle gets wiped off the planet one day.
So is there anything that we're doing with these thoughts?
No. Fortunately, contrary to what you'll see in science fiction movies, there is nothing that we can currently do that affects this long-term crustal cycle. Thank God. No, we would not want to do that. Okay, we don't want to mess with any of these processes. Okay, folks, we vastly disrupt what's going on on Earth. There are two movies from the 90s. And Dante's Peak. Which every once in a while, I'm like, I just want to watch a bad science fiction movie.
Oh, it's so good. So
They're
bad.
so bad. Like they like stop lava with like concrete highway fighters. It's like, just doesn't. No, that's not it. Okay, that will not save us. Yeah, go back and watch those movies this weekend. You'll see this type of ring of fire volcanic effect played out large. But these are very dynamic processes. When they explode, when they erupt, you have localized influences both on people and organisms around them. And again, you can watch those bad movies in order to see what happens.
The rock's in one of them.
I was gonna say, I think like The Rock and Samuel L. Jackson are in
Right, it proves that if you strain hard enough at any task, your strength will overpower natural disaster.
Right,
You're overriding.
they are definitely in that. Okay, the other thing that we have that features prominently in the United States are transform faults, and these are when plates are moving against each other. They're moving past each other, not really pressing up against or moving away from each other, but they're rubbing against each other, and they catch. Okay, and as they are caught on each other, then they build up tension and friction. When that releases, then you get an earthquake. And so we have big transform faults again in the western United States. This is the San Andreas Fault, which runs through California, offshore California up into Oregon. This is what's happening along the ridges and faults along the Juan de Fuca Plate, which is up again in the Pacific Northwest. We have smaller breaks within tectonic plates that produce things like the small earthquakes that we have here up into the Adirondacks and Appalachians. There are small transform faults within places like the Ozark Mountains down in Missouri and Arkansas, Oklahoma as well. Okay, how cool is that? It's very cool. Okay, and as far as a variety of bad questions. Okay, like don't ever watch The Four. Ooh, Beyond the Pale. Okay. All right. These plate tectonic processes produce the geologic cycle. And again, we can think of the geologic cycle as the rock cycle, which maybe unfortunately Dwayne Johnson doesn't have anything to do with. But we can think of the geologic cycle or the rock cycle as this interacting physical and chemical processes that transform the Earth's rocks from one type to another. So just as the crust is in a cycle process, just as in the mantle has a cyclical flow to it, the production of rocks that come from the cooling of magma into other types of rocks happens on a continual basis. And it's very, very slow, but it creates deposits of certain minerals in certain locations in the crust that then we have found that we can take advantage of. But those mineral deposits are a direct result of this geologic cycle and these processes that are happening on a continual slow basis within the Earth's structure itself. Okay. We only have to work with what we essentially started with. Okay, when the Earth condensed out of interstellar dust, we've got a certain number of elements. We got a certain quantity of those elements, and that's what we have. That's what forms our Earth. We've gotten some additions from a whole bunch of meteors and asteroids that have hit the Earth, but by and large, what we have is what we have. Okay, we are not going to suddenly get a new source of gold. Okay, we might find a new gold deposit, but we're not going to suddenly find that there's a ton of gold laying over the surface of the Earth until these geologic processes take place and transform the rocks that we currently have into other types of mineral deposits, and that takes a long period of time. In general, there are three processes that compose the geologic or rock cycle. There's metamorphism, and this is when the heat and high pressure of the earth in the mantle and the crust transform rock of one type into another type of rock. Okay? Okay, this is when we go from shale, which is a sedimentary, slate, which is a metamorphic rock. Okay, the metamorphic processes or metamorphism produces metamorphic rock types. Okay? The other big process that we're very familiar with is erosion. So wind and water can scrape away, can dissolve the minerals that are in existing rocks and release them then to be laid down in other places as different types of rocks. Okay, so erosion breaks apart existing rocks and it produces sedimentary rocks when those mineral particles are laid down in another location. Okay, this is wind and water erosion taking topsoil from the agricultural regions of the United States. It flows down as sediment kind of pollution to the Mississippi River, and then it gets laid down in the Gulf of Mexico as a layer of dirt at the bottom of the ocean that will get compacted into sedimentary rock there. All right. When these plate boundaries are divergent and you have lava that's coming back up to the surface, you get these sedimentary metamorphic rocks that are melted by the really high intense pressure and heat of the Earth's mantle, and then they explode back up or slowly pillowed out onto the seafloor, usually where this happens, or they explode out in volcanoes. And when that lava solidifies, it forms igneous rock. Okay, and so most of the bottom layer of bedrock of the Earth, both under the water and on land, is igneous rock. We've got the salt on the bottom of the oceans, and we've got granite as the main kind of igneous mineral that's underlying our terrestrial portions. Okay, everybody with me? Rule 3. You can take a class if you don't. You can take more than one class. All right. The result of these different geologic processes, for our purposes today, is the production of minerals. Okay? And minerals is a naturally occurring element, it can be composed of a single element, or it can be an inorganic compound. We've got a couple different elements bonded together covalently, ionically. And they have a regular crystalline structure to their solid form. Okay, so you can have one element, or you can have an inorganic compound, and it exists in the Earth's crust with a crystalline, solid molecular arrangement. Okay? Diamonds are an excellent example of a crystalline mineral. Okay? If it shines, black light.
If you like it in your
Probably a mineral. Okay? And for some reason, we like shiny things. We have for a long time. All right. There are tons of naturally occurring minerals. There's all different elements as well as compounds that can be out there in a variety of different forms. There's about 100 different minerals that we commonly extract for reasonable profit. Okay. You can go dig up in your backyard and you will find a whole bunch of interesting rocks that have minerals attached to them that you might find interesting, but it's not like you can sell them to make money. Unless you make a really cool rock collection. There's about 100 that we commonly mine in mineral resource extraction. Recognize that there are 60 different minerals in one year. And so as technology has advanced and our ability to extract and refine these minerals has improved, we're increasingly dependent upon them, some of which are very rare and exist in only a few known locations on the Earth's surface. Remember, we have what we started with, okay? And the production of new minerals is reliant upon the geologic cycle, which takes millennia to transform one type of rock into another, create a new mineral deposit. Yeah. Yes. And so much of our production of things like computer chips and electronics today is increasingly trying to move towards reclamation and reuse of what we have already mined, and putting that into the same use again, or refining it in a different process so it can be used again, rather than trying to find a new deposit and mine it out of that location. Okay, everybody with me? All right. Okay. When we think about these minerals, we can shift for a moment into an economic perspective of why we need these things and when they become of interest to us. A scattering of gold throughout your backyard is not useful, okay? It doesn't exist in a concentrated enough deposit to actually be mined for profit. It's out there, okay? But it's not concentrated enough to be useful. So we talk about mineral supplies and mineral deposits, and it's all about how concentrated that particular mineral is at that location. Okay, so our mineral reserves are identified deposits of a particular element or mineral, and they can be extracted profitably because there's a high concentration of that. So when you take out that rock, you can get enough of something that you can process it or manufacture or straight out sell it to make money. Okay, think about the gold rush to the western United States that happened in the 1800s. Everybody was out there looking for gold and silver veins. They were looking for the places where there was a high concentration of this particular element that they could mine to then make a profit on. Okay, if there's not a whole lot there, you can't really mine it and make a lot of money. There has to be a rich deposit there to be profitable. All right. The length of our supply for these minerals is very dependent upon the finite amount of that element or mineral that's present on Earth and the time that it takes for the Earth to regenerate that particular mineral. And this gets us into an idea of supply and demand for these different minerals. We want our reserves to last indefinitely. We want to be using and mining, extracting these valuable commodities at a sustainable fashion, where we can continue to pull out a certain amount each year. We will use that amount. The Earth will provide for us the same amount year after year after year. The difficulty, like with modern agriculture, comes because of our increasing human population and our increasing reliance upon mineral resources. As there are more and more of us, as we have a more technologically advanced society, we consume more mineral resources each year, to the point that we're consuming them faster than the Earth is producing them or replacing them in its geologic fashion. Us as American citizens, we definitely have the greatest natural mineral resource use. You and I use about 24 tons of mineral resources every year. And you think, wow, the Earth is vast and it is large, and that is true, but there's a limited quantity of each of these minerals that we can actually physically get. Okay. And it is important to consider where these mineral deposits are. Okay? The United States does not have access to many of the mineral resources that we utilize in our industrial manufacturing processes. We buy them from other countries whose land encompasses the territory where that mineral is deposited. That makes some countries very rich and other countries very poor. And that again adds to some of the imbalances that we see in economic productivity around the world. Okay, all right. So in terms of mineral supplies and deposits, we are looking to mine ores. And ores are rocks that contain a mineral in a high enough concentration. And the brackets here around the word indicate concentration. We're doing a little bit of chemistry. Don't freak out. An ore has a high enough mineral concentration for its extraction to be profitable. And so a mineral deposit is a place where you will find a high concentration of hopefully high quality ore. High quality ore then is one that has a high concentration of a profitable mineral. And a low grade or low quality ore has a lower concentration of that mineral. And so when we find a deposit, we want to mine the high grade ores out first, because that will make us the most money. It has the highest concentration of the mineral. And we're going to mine the low grade ores second or last. As our technology changes, we have greater and greater access to some of our low quality, low grade ores. Mines that have been closed because we thought we'd mine them out. As we get new chemical or physical processes for mining, some of those mines reopen because there are still low grade ores there that we can access. And there's always this trade-off. How much money does it take to extract the mineral resource versus how much money am I going to make? And if that's a to make money, then we mine it. If it's going to cost us too much money to get out the ore, then we leave it until the technology changes and it becomes profitable. We do all kinds of mineral mining. We mine certain metals, which tend to be elemental solids at room temperature and 1 Earth atmosphere. Things like copper and zinc and gold and aluminum, iron, silver, lead. Other non-metal metals that can be helpful to us are things like magnesium and molybdenum, things like phosphate, utilized of course in fertilizer as well as in other areas. And then we have, I want you to recognize that it's not all about these metals, which definitely get the biggest billing when it comes to electronics and technology today. But there are other non-mineral, non-metal, mineral resources that we use a lot of. And things like lime, which again is used in fertilizer production. Things like sand, which we utilize in a wide range of industries. Things like making concrete, as well as things like making glass. Things like gravel, okay? Think about all the places that you see gravel in our kind of modern urban environment, okay? It forms the pillar foundation for all of our buildings. It's the thing that underlies all of our roads, okay? This has to be mined and found, okay? It doesn't just pop up, okay? There are certain places where these minerals are enriched, and that's where we go and mine them from, okay? All of our mineral resources are what we call non-renewable. Okay? It takes longer than a human lifetime in order to regenerate that. So our use is potentially very unsustainable when it comes to our extraction, just in terms of a supply and demand market aspect. Okay, any questions so far? Okay. My last slide before we start in our activity today, and then we'll see if we come back after our activity, has to do with rock. We talked about minerals, we talked about ores as a rock that has a high concentration of mineral in it. And now we can talk about what is a rock. Okay. A rock is a solid combination of one or more minerals. And again, they can come in a whole bunch of combinations. You can have the same element in combination with a whole bunch of different atoms, and it'll give you different rocks. Again, we recognize there are three basic types of rocks. Sedimentary rocks, which are laid down in a layering fashion, like we see in the Pennington Desert here in this canyon. You have these different strata in the rock. That's a sedimentary rock. It's the result of biological and erosional processes on the Earth's surface. Limestone is an excellent example of a sedimentary rock that's produced from the solidified shells, largely of living organisms that utilize calcium carbonate in their shells. When they died and their shells solidified, they make limestone. That's a sedimentary rock. Okay. Igneous rocks are from the cooling of lava on the Earth's surface. These are things like pumice and basalt. Think lava flow, any of the rocks that you find around there, obsidian, lava glass, right? Those are all our igneous rocks. Okay, their erosion produces the sedimentary rock material. Okay. When sedimentary rocks are transformed, as they get deeper and deeper in the Earth's crust by the heat and pressure they're subjected to, they undergo metamorphism and they make metamorphic rocks. Yeah.
Why is it limestone that builds up in washing machines and stuff like dishwashers?
Oh, it is. It's lime. It's very kind of similar in composition, where you get like a calcium phosphate buildup, and you get that chalky material that you see on there. That's deposited again by all this water that you utilize in the ions that are in it. As it builds up and solidifies on the metal parts, usually, then you start to build rock, essentially. There, you got your chip it off, right? Yeah.
We use like say 24 tons of minerals here. How many do we actually need?
Ooh, how many do we actually need? Well, I think most of us would say 24 tons. The things I have are the things I need. When it had to look, Willow, to be sure, I think it's appropriate, and hopefully you will come to this place as we talk about mineral extraction, that what you want and can utilize in terms of mineral resources is perhaps quite different from what you absolutely need. And so, do I need the latest iPhone? I'm going to pick on them because I have one. Do I need the latest iPhone?
No.
Right. It's a factor of how long since I got a phone. Do I have the economic resources? Is there a new feature that I have to have for my job? You know, those are all questions that come into whether or not I really need the newest, latest iPhone, but like I have friends that like as soon as that sucker is like out, they're like in line waiting for it, and I'm like, you bought the last one, okay? Like, do they need one? No, their screen's not cracked, it's not broken, they did not have their child drop it in a toilet, like, okay? So, that's a big player when it comes to mineral resources. Do you have to have the 60-inch television?
Depends on who you're talking to.
No. But yes, right? And so, our society has changed quite a lot, and our mineral use and misuse is a direct consequence of that. And so, as our economic stability has changed, as our economic abilities have changed, our mineral resource has increased exponentially. Do you need it? Perhaps. And that's where exactly what need means is going to vary for everyone. So like my computer that I regularly use, I bought used from a friend, and I honestly, it's probably like at least 8 if not 9 years old. Do I need a new computer? I could sure do with one. And every time my husband suggests it, I'm like, but it's not broken. I don't, especially with the cloud now, right? And I can store stuff not on my actual hard drive. Like, I don't actually need one. But sure, I could use the latest model. I'm sure there are features that would make it a little bit efficient. And so I think that complicates this question of what are essential mineral resources. Okay, yeah. Okay.
Also, when it comes to tech like that, there are those conspiracies around, like, mainly around iPhones, that they get slower and they start, like, wearing down. You know,
Oh,
and
yeah.
things
So,
that come out.
excellent point. The companies that base their productivity on these types of products, there is a fine line between building them to last and building them to last, okay? My mom, for instance, has the same vacuum cleaner that she had when she got married, like 45 years ago. Okay, the thing is a beast. It never breaks, okay? Like, I'm constantly replacing the belt on my vacuum cleaner, okay? To the point where, again, we're like, should we buy a new vacuum cleaner? And I'm like, but I can fix this one, rather than putting in the resources and the money to buy a whole new one that will probably break within 5 years. So, again, the way that we build products has as that the lasting factor is no longer a limiting quality for people, that they're able to buy as soon as it breaks. That is not the way our society used to be, and it has a consequence of these types of mineral uses. Both in terms of waste that we produce, which is where we're going with this conversation too, as well as these types of funding resource optimization. It's a great thing. What I want us to do next is take a look at some mineral and rock specimens. Does anybody recognize this diamond? The Hope Diamond, okay, the largest diamond on the planet currently that has been like pulled out, stolen several times, now a resident of the Natural Museum of History at the Smithsonian Institute in Washington, D.C. Gorgeous thing, mounted very beautifully, of course. I can't imagine ever like wearing it. I don't know what it's carrying. Yeah, it's warm, it's so big. I have to look, I'll look here while you guys are doing work on what its actual carats are. I want to say it's like,
It's huge because Tiffany in New York has one that's a canary one that's like 30
Oh,
carats,
okay.
and it's like
it's your fist. I've seen it. It's this big.
it's a casual accessory.
Yeah. I don't know how you carry this sucker around, right? Okay, so what I'm looking for you to do, I have materials for 4 groups today, so there probably needs to be at least 3, hopefully 4 people in your group today. Come up to the front. I'll give you a worksheet and a bucket of